Hi students, in this particular class we will try to understand how can we calculate the performance of CPU in terms of its execution time with respect to the number of instructions, with respect to the clock rate. So as we know that the most of the digital electronic circuit performing its functioning on the basis of the clock signal. So by using the similar approach, mostly all the computers are using a clock signal which is running at a constant frequency. So a constant frequency clock signal is required to perform the operation of computer. These discrete time events are known with different names. These are ticks, clock periods, clocks, cycles, or clock cycles. Mostly we will call it as clock cycles. So whenever the computer designer will have to evaluate the performance in terms of CPU time or execution time, they will have to evaluate the performance of the computer, or they will have to predict the performance of the computer by referring the time of the clock period. Whatsoever the time period of the one clock period will be there, it will become the reference. So by referring the clock period, the designers are evaluating the performance of a computer. So in some cases, designers are also using the clock rate. So what is clock rate? Clock rate will be inversely proportional to the clock period or clock cycle, or the time duration of the clock cycle. So basically clock rate will be the frequency of the clock signal, and clock cycle will be the time taken to complete the one cycle. So it will be the duration of the one cycle of the applied clock frequency. So before we will discuss the CPU time for a program, how can we evaluate the time for a CPU time for a program, we will try to understand, or we will try to recall certain concepts. As we already know that to perform any task in the computer, we will have to write a program. So as per the definition of the program, if we will go with the definition of the program, then the program is having a set of instructions arranged in such a way that which can be, or which will be able to perform a task. So in other words, we can say that one or more than one instructions will be there in a program, and all those instructions will be arranged in a sequence, so that particular sequence must be able to perform or execute one task. So nutshell, if we look broadly what is the program is a combination of instructions. Now we will try to look at what is instruction. Instruction is a command which is used to perform a task. So now how much time instruction will take, that will depend upon how many clock cycles instruction will consume. So the number of cycles consumed by one instruction will decide the how much time instruction will take, and the number of cycles required for one instruction is processor dependent. If processor is CISC, then the number of clock cycles will be different for the different instructions. But if the processor will be of RISC type, then the number of clock cycles required for one instruction will remain same. So nutshell is there will be clock cycles per instructions. This is the one term. Then number of instructions in a program. This is another thing. If we want to calculate the time for a program, one method or one equation can be written as CPU clock cycle for a program. So in the end, the basic unit which will be referred to calculate or evaluate the time for any program for CPU, that will be the clock cycle. So if we know that how many clock cycles a CPU is required to complete one program, and if we know what is the time of one clock period, then we can calculate how much time a CPU will take to complete that particular program. What we must know: one, how many clock cycles are required to complete one program by a CPU, and what is the clock period of one clock cycle. By getting the product of these two things, we will be able to get the CPU time for a program. The another method is CPU clock cycle for a program. These are the number of clock cycles required to complete one program upon clock rate. So what is the clock rate? Clock rate is 1 upon clock cycle time. It is 1 upon time of one clock cycle. So it is the frequency. So if we know the frequency and if we know the number of clock cycles required to complete a program, we can also calculate the CPU time for a program. This is the method to evaluate the CPU time for a program by knowing the clock cycles for a program. So now how can we calculate the clock cycles for a program? If we know the number of instructions for a program and if we know the number of clock cycles for one instruction. If we will go with RISC, then naturally the number of clock cycles required for each instruction will remain same. But in case of CISC, the number of clock cycles required to complete one instruction may different as compared to the another instruction. So if we want to know the clock cycles and instruction count in a program, then how can we calculate that? That can be calculated. The CPU clock cycles in a program means how we will be able to calculate the CPU clock cycles in a program by knowing what? How many instructions are there. IC is here instruction count, number of instructions. So how many instructions are there in that particular program, and by knowing the clock cycle per instruction. So what is the clock cycle of one instruction? So by getting the product of these number of instructions into clock cycles per instruction, we will be able to calculate the clock cycles for a program. Okay. In other words, clock cycle per instruction can be calculated by knowing the how many clock cycles are there, or if we want to calculate the number of clock cycles per instructions, then how can we calculate? This can be calculated by knowing how many clock cycles are required for a program divided by number of instructions or instruction count. Here we are using IC for number of instructions to execute a program, and CPI is the clock cycles per instructions. So by using this we can calculate, by knowing this we can calculate the CPU time for a program, and this can be calculated either by knowing the CPU clock cycles in a program multiply by one clock cycle, or we can calculate the CPU time for program by knowing the clock cycles for a program divided by clock rate, which will be the frequency of the clock. Now the CPU time for a program can also be calculated by using the instruction count or number of instructions, and by using the clock cycles per instruction, and by knowing the time period of the one clock cycle. So then the resultant equation to calculate the CPU time for a program will become number of instructions or instruction count into clock cycles per instruction into clock cycle time, so or the time period of one clock cycle. So the same CPU time for a program can also be calculated, or by replacing the clock time with clock rate. As we know that the relation between the cycle time and clock rate is inversely proportional. So clock time will be equal to 1 upon clock rate. So by replacing this we will get IC into CPI upon clock rate. So in some application there is a need to calculate the clock cycles for the CPU. So if more than one program will have to be run, then we will have to calculate the number of clock cycles for each program. This is the one way. Either we can calculate the instructions, number of instructions and clock cycle per instruction for each program, and then sum of all the clock cycles of all the program will be the clock cycles of the CPU. So if we will go and try to summarize this in one equation, then it will become sum of product of all the instructions count into clock cycle per instruction. So we will take the sum of all these. So then the equation will become CPI, sum of all the CPIs into IC, where the value of I will go from 1 to n. If there will be n number of programs, then we'll have to get the product of all the instructions number of instructions and number of clock cycles per instructions for each program. So by using this, we can calculate the clock cycles for CPU. So to calculate the overall performance of CPU for a task, where ICI is the number of times the instruction I will be executed in a CPI of I is the average number of clock cycles for instruction I. So by knowing the CPU clock cycles, it will be easy for us to calculate the CPU time, and we can calculate the CPU time by multiplying the clock cycle time with the number of clock cycles, CPU clock cycles. So number of clock cycles will be replaced over here and it will be multiplied with the clock cycle time. So how can we calculate the overall CPI? The overall CPI can be calculated with this particular equation. Okay, so by using this methodology or by using these equations, we can calculate the performance of CPU. So these are the different equations which will be used to calculate the performance of CPU. Now we will try to understand what will be the CPU performance with the help of one example. In this particular given example, this is the given example in which 1000 instructions have to be executed in a program, and the operating clock frequency of the CPU is 1 gigahertz. So now we will have to calculate the time of the program or execution time of the program. So as we can see that in this particular table, the different types of instructions are given, different classes of the instructions are given, and we can see that in each class the number of instructions are different, and at the same time the CPI is also different. All the CPIs are different, means the number of clock cycles required per instructions are also different. So as we know that what is the equation which can be used to calculate the execution time of a program, the execution time of a program can be calculated by using IC into CPI upon clock rate. As clock rate is given, so IC is also given, 1000 total instructions are given, but CPI is not given. CPI is given, but this CPI is different for the different functions. So before to calculate the execution time, we will have to calculate the overall CPI. We'll have to calculate the overall CPI, and the overall CPI can be calculated by using this equation, and by putting the value of given instruction count and CPI in this particular equation, we will get the overall CPI, and overall CPI will be 1.8 in this case. And after putting the value of IC, which is 1000, and after putting the overall or average CPI of the program, it will be 1.8 upon the clock rate, but clock rate is 1 gigahertz, so it will be 1 into 10 raised to power 9. So that execution time of the program will be 1.8 microsecond. So this will be the time taken by the processor, which is having a clock frequency of 1 gigahertz and will have to execute 1000 instructions with the different counts and different CPI. So by using this particular example, we will be able to calculate the execution time of a program in which different types of instructions are there with the different types of CPI. Next is performance can also be evaluated in terms of MIPS. This is another unit which is used to evaluate the performance, and it is called million instructions per second. So it is also gives us the idea about the rate of execution per unit time. So as its name is indicating, million instruction per second, so it is used to evaluate the performance in terms of million instructions per second, means how many million instructions a processor will execute in 1 second. Okay, so the MIPS can be calculated by knowing the instruction count, the total number of instructions. If we know the total number of instructions of a processor upon the execution time into 10 raised to power 6. Here the 10 raised to power 6 is to count it into or to convert it into million instructions per second. As we know that what is the CPU time, it is IC into CPI upon clock rate. Therefore by substituting the value of IC we will get MIPS can also be evaluated with respect to by knowing the clock rate, CPI. By knowing the clock rate and CPI, we will be able to calculate the MIPS. This is a million instructions per second. From this equation, we can see that the MIPS is inversely proportional to the execution time and directly proportional to the performance. So one thing we can conclude, the faster the machine, larger the MIPS rating. So as any machine which is very fast will gives us the larger MIPS rating. So depends upon the instruction set as well. So the MIPS is also depend upon the instruction set. So again, if the instruction set of the two different processor is different, then we cannot compare the performance of the CPU in terms of MIPS, because the MIPS is depend upon the instruction set, because the CPI is a very important part over here. So as the instruction set will change, CPI may change. So that is why we cannot compare the performance of two different processors with the different instruction set. So now we will discuss another example to understand or to evaluate the CPU performance. This particular example is for a machine with three different types of classes: class A, class B, and class C, and each class is having different types of CPI, clock per instructions. So these are the specifications given for the CPU or a machine. Now if we want to use the same machine for a high level language programming by using the two different compilers, and this will be the input of the compiler, and we'll have to find out the performance of these two compilers with respect to the MIPS and its CPU time. If we look at the given inputs, then we will find for compiler A, 5 million instructions are there, will have to be executed by the compiler 1, and this will be of type A. For type B, 1 million. Then for type C again it is 1 million. Okay, so for compiler 2, 10, 1 and 1 million instructions will be there for A, B and type C respectively. So to calculate the MIPS of these two compilers, we will have to use this particular equation, which is clock rate upon CPI into 10 raised to power 6, and it will be 100 megahertz upon CPI into 10 raised to power 6. So as we know that it is the CPI, so we will have to calculate the CPI, because this given CPI, the three different CPIs are for three different type classes of instructions. So we will have to evaluate the first of all CPI. So CPI will be evaluated by using this equation. So for compiler 1, the CPI 1 will be equal to 5 into 1 plus 1 into 2 plus 1 into 3, where 5, 1 and 1 are the number of instructions, and that second part 1, 2 and 3 are the CPI for each class. Okay, so this will gives us the CPI, which will be equal to 1.43. so this will be the overall CPI of the compiler 1. So to calculate the MIPS, we will use this particular equation, which will be the clock rate upon CPI into 10 raised to power 6. So by putting the value of clock rate and CPI, we will be able to calculate the MIPS rating of the first compiler or compiler 1. So it is 70 million instructions per second. Similarly, we will calculate the CPU time as well. So the CPU time will be the instruction count into CPI upon clock rate. So first of all, we will calculate the instruction count. Instruction count for compiler 1 is 5 plus 1 plus 1, which is total 7 million instructions are there. So that is why it is 7 into 10 raised to power 6 into CPI. CPI is 1.43 divided by clock rate. Clock rate is 100 megahertz. So that is why it is 100 into 10 raised to power 6. So CPU time will be 0.1 second. So these are the calculations. The MIPS rating, million instruction per second rating for the compiler 1 is 70 MIPS, where the time CPU execution time is 0.1 second for a program which will be executed by the compiler 1 with the given inputs. Now we will try to evaluate the performance for compiler 2. In the similar case, we will first of all calculate the CPI. It will be 10 into 1 plus 1 into 2 plus 1 into 3 upon 10 plus 1 means total 12 million instructions are there. So the calculated CPI will be 1.25, and by using this CPI in the equation of MIPS rating, we will be able to evaluate the MIPS, and it will be 80 million instructions per second. Okay, so now we will calculate the CPU time. The CPU time for compiler 2, the CPU time for compiler 2 after putting the values and calculation, we will be able to get the CPU time is 0.15 seconds. So now we will have to compare the performance of compiler 1 and compiler 2. As we can see that the compiler 1's million instructions per second are 70, but its execution time is 0.1 second only. And on the other hand, the MIPS rating for the compiler 2 is 80 million instructions per second, and the CPU time is 0.15 seconds. So what can we conclude from this? From this, one thing can be concluded that the MIPS rating indicates that the compiler 2 has the better MIPS rating as compared to the compiler 1. But on the other hand, if we will go and look at the CPU execution time, the CPU execution time of compiler 1 is faster. Okay, so what can we conclude from this? A higher MIPS rating in many cases may not mean that the higher performance or better execution time. That is due to the compiler design variation. So not only MIPS rating will decide the execution time, but the design of the compiler will also decide the performance of the CPU. So this is all about how can we evaluate the performance of the CPU. Thank you.